Hi there, this is exercise 7B.2. So we've already seen how to find the median, the quartiles and the mode of a continuous random variable, and today we're going to do the mean and the variance. And this picture here just shows us a little bit about it. And you can see in the picture it says if you have a symmetrical distribution, the mean is right in the middle. So I suppose it's not that. The mean is, another word for the mean is the expected value. So it's if this can take a range of different values, that might be, I don't know, 0, it might go up to 10, and the probability of getting any value of x was determined. So I'm trying to make this a bit of a posher diagram, really. I suppose this is the PDF now, isn't it? Probability density function, and you can see essentially it's obviously the middle value is 5, where it hits its maximum value. So the mode is there. The median, half of it is on either side, and also the expected value is 5 as well. And I have said to you, if you ever get a question where it's symmetrical, you can just write down straight away that the expectation, the mean, the average, if you like, is E of x is 5 in this case. It's, just by symmetry. But if it's not symmetrical, if it's skewed one way or the other, we have to use integration, and this lesson is about showing you how to use that integration. So a little starter for you. This goes back to some statistics we've seen in maths and further maths before, where if I wanted to find the mean E of x and the variance of a discrete random variable, you should remember this formula, which is basically to find E of x, you go, well, x can only take these values, 1, 2, 3 and 4, and these are the probabilities. So what we do is we times, and we do 1 times by the 0.25, and then we add the 2 times by the 0.1, like that, then that, then that. So plus 3 times the 0.4, plus 4 times the 0.25. I don't know what that is, but I'm going to type it in. So first one, so I get 53 over 20, 2.65. I've just quickly typed that in. So 2.65. And that was relatively straightforward. And then we have this second formula that says, in order to find the variance, the spread of the values, we have to use this form, which has an E of x squared. So to get E of x squared, which I have to do first, I do not just 1, I do 1 squared times that number, because it says x squared, plus 2 squared times by the 0.1, plus 3 squared times by the 0.4, plus 4 squared times by 0.25. So you'll notice the probabilities don't change, but the x values do. So let's just do that. I'm typing it in now. And I get 33 over 4, which is 8.25. And I just finished this off by saying the variance is that 8.25 figure. And my formula says now take away the 2.65 figure, the E of x, but I have to square it. So minus 2.65 squared equals, and I get 1.2275, so 1.23 I suppose to 3 sig figs, or if I prefer I could give it exactly because it doesn't go on forever. So let's see what I got as the answers. 2.65, that's right, and 1.2275. So I wrote it completely. 3 sig figs would have been fine. So that's a reminder of an old rule. And another reminder for you would be this. Now, we've seen this question before. It actually says a continuous random variable has this probability density function. So if I draw the graph for this, you should recall that this is a sine graph, and as long as I'm in radians, it basically goes up and down like that, and at pi it comes back to 0. It goes up to a maximum value of 1 at the halfway point, which is pi by 2, and it obviously starts at 0. Now before that and after that it's 0 because it says otherwise, 0 otherwise. That's a picture. Write down the value of E of x. Well, it's symmetrical, and because it is symmetrical, it's very quick and easy to do this. Therefore, E of x is the halfway point. Look out for the easy ones, pi by 2. If they're not symmetrical, as I said before, this is the approach we have to integrate. But notice we're not integrating just the function. There's the inclusion of an extra x here. So to find e of x, we have to do the integral of x f of x. Likewise, to find e of x squared, we have to find the integral of x squared f of x. And there's one more, which is, and I'm hoping you're looking at this thinking, oh, they're very similar to those formulas that you just made us do at the starter, and they are. So we're going to come to these three formulas now. So it should be a fairly straightforward one. I'm just looking at the equation here. It doesn't look a hard one. It simply says that f of x is a fifth. So if you were to draw the probability distribution for this, it's between 0 and 5. It has a set value of a fifth, or 0.2 I suppose. And that seems reasonable because if you think about the area of this thing, 0.2 up 5 across, can you see that area equals 1? And I've already said the area must always equal 1 on these. Otherwise, anywhere else, it is equal to 0. There you go. So that's my distribution. Find the mean. Well, the mean is actually dead easy. E of x, can you see it's symmetrical? E of x must be therefore 2.5. I don't have to do any work at all for that. It's just bang in the middle. The other one may be a bit harder. E of x squared, it says I have to integrate. Now this is the trick. You integrate between 0 and 5, because that's my area. And you have to insert an x squared. Because I want e of x squared, I insert an x squared times by my function, which is a fifth, dx. And that's obviously a fifth of x squared. So I add a power divided by the power. I reckon I get x cubed over 15. Now again, that's between 0 and 5. So if I put 5 in, I get 125 over 15. And if I put 0 in, I get 0 out. So that's actually the answer. So that's e of x squared. Now remember, I'm after the variance. So the variance of x is 125 over the 15 minus, now I have to do 2.5 squared. And if you can't work out what I've done there, all I've reminded you really of is I've said that the variance is e of x squared minus e of x squared. So there's a difference between these two things, obviously. I don't know what the answer is, by the way. So 125 divided by 15 minus 6.25 squared. And I get, oh, I typed it in wrong. 125 divided by 15 minus 2.5 squared. That's better. 2.08 I get. 0.8333 recurring. So let's see what the answer actually are. 2.5 is right, 2.08, yes, we've got those right. And I've got another example for you. This one's probably better because this will, well, to a certain extent it might do, it might not. I mean, one thing I don't like about this question, for instance, is the fact that I just wrote 2.5 down and it didn't highlight that I could have used integration. Let's use integration before I move on. So here's e of x. It equals then, if I was to find this, say I didn't spot that it was symmetrical, I could do this by saying, what's the integral? And when I did e of x squared, I had to insert this x squared in, when it's e of x, I just insert the x in, times by a fifth dx between 0 and 5. So that's a fifth x. If I was to add a power and divide by a power, that becomes x squared over 10. Now remember what we're doing, you're doing this between 0 and 5. So if I do that, 5 goes in, that's 25 over 10. And if 0 goes in, I get 0. So it's still 25 over 10, which is 2.5. So notice, that method has worked here. And if I didn't spot it was symmetrical, that was the way to do it. Now this one, first of all, it doesn't tell me what k is. And I think I'll probably need to know what k is. So without knowing k, I'm going to have to do a bit of work. So to find the k, do you remember from last time, I think it was exercise 7a we did this, you integrate, in this case from 0 to 10, of the function. I'm going to multiply out the bracket, so it's 10k minus kx dx. And notice on this, because I'm just trying to find this, this is almost like I'm using the idea that the total of the probabilities equals 1. So this answer has to equal 1. And so when I do in this, I didn't insert an x, I just did the integral of f of x dx equals 1. Now remember, if I ever want e of x, for instance, I have to insert that x f of x. So there is a difference here, but they're very similar. So just look out for that. This one gives me the probability type argument, which is why I've set it equal to 1. Anyway, let's add a power, divide by power. There was no x's at all there, so it just becomes 10kx. And this has got an x, it becomes kx squared divided by 2. Add a power divided by the power. 0 to 10 equals 1. Well, I better put 10 in. That gives me 100k. Remember, the 10 is the x. And if I put here, I get 100k over 2, which is, of course, 50. And that equals 1. So that means I've got 50k left over, equal to 1, and therefore k is a 50th. So at least I know now what k is. If I want e of x, it's the integral of x f of x. Now f of x is this thing here. And I now know that k is a 50th, times by a 50th of 10 minus x dx. So I don't like the bracket, so I'm going to get rid of the brackets. It becomes, I can even take a 50th out and chuck it to the front. It makes it easier. And then I get 10x minus x squared dx. And don't forget, this is between 0 and 10. So I'll keep going. 1/50th. If I integrate that, I get 10x squared over 2, which is 5x squared, minus x cubed over 3. Now be aware, these are all starting at 0. They're not always at 0. Sometimes they're different numbers, so you need to look out for that. And if it starts at 2, set it to 2. That's a 50th of 5x squared goes, if I put 10 in, that's 100, 500, minus, that's 10 cubed, that's 1,000, and that's 333.3. All times by a 50th, of course. So let's do this. 500 minus 1,000 divided by 3, which is the actual answer, divided by 50, and it's actually quite not a bad answer. It's 10 over 3. Okay. Now, obviously, I had to do that properly because it wasn't symmetrical. Let's do e of x squared. Very similar. That's the integral of x squared times this thing. Well, I can put 50th straight out there, and effectively, if I do that, make that an x squared, I get higher power, so it becomes 10x squared minus x cubed dx between 0 and 10. If I do this, I get a 50th of add a power, so that's 10x cubed over 3 minus x to the 4 over 4 between 0 and 10. And this equals a 50th of, if I put 10 into that, it's 10 times 10 cubed, and then divided by 4, 2,500. I figured it would be a nice answer. Minus, that's again 10,000 divided by 4 is 2,500. Oh, that's divided by 3 on the first one. Alright, so this one's 3, 3, 3, 3 when I do it. Minus 2,500. So 3333 minus the 2,500 divided by the 50 at the front, and I get 16 2/3. So the var is 16 2/3 minus 10 over 3 squared. So minus 10. And I get 5 5/9, I think that is. It's 5.55 on mine. 5.5, oh sorry, it's exactly the same. So anyway, it's exercise 7B. You should now be able to do the rest of it. Best of luck. I hope that goes well. So hopefully you can do the mean now.